let's use a particular technique that, let's say, an advanced technique. One advanced technique would be to focus on, so we have 16 people, and of them 5 are girls. And one of the ways that we could look at this particular problem in terms of selection would be this idea of 16 people, 5 girls. We could actually break it up into the following. Note, all teams, the cardinality of all teams would have to be having no girls or exactly 1 girl or exactly 2 girls or exactly 3 or exactly 4 or exactly 5. So one way of looking at particular problems when you're wanting to break them up into groups like girls and guys would be understanding that all the teams that you have could be split up into disjoint groups of a no girl group, exactly 1 girl, exactly 2 girls, exactly 3 girls, exactly 4 girls, exactly 5 girls. And I could solve each of these if I want. For example, for all teams, well, what is all teams? Well, for the 16 people, let's go ahead and choose 10. So that's 16 factorial divided by 10 factorial, 6 factorial. On the other hand, what would be the cardinality of no girls? Well, that would mean it's all guys. So that would mean for the 11 guys, I'm going to go ahead and choose 10. So that is 11 factorial divided by 10 factorial, 1 factorial. And then we could go through here and have, for example, we've already done the exactly 3. I could do the exactly 2, which would be from the girls choose 2, and then from the guys choose 8. And so that would be 5 factorial over 2 factorial, 3 factorial times 11 factorial over 8 factorial, 3 factorial, whatever that number is. But seeing this particular form, right, we could actually add some different questions. We could say things like, the exactly 2, 2, 4, 3, 4, and 5, this entire group could be called, for example, at least 1 girl. So if I would add up these 5 things, that would be the same thing as asking, hey, how many teams have at least 1 girl? But on the other hand, because this is an equality, I could find these 5, which take a little bit of work, but I could just simply move this across as a subtraction, and it would solve the same problem. So that's also a counting problem, right? We can go through these and solve different problems. And if I asked for at least 2 girls, I would say I would need this group, and then this group, and then this group, and then this group. The last 4 put together would answer the question of at least 2 girls. So this equation here of knowing that all teams equals no girls, exactly 1, or exactly 2, or exactly 3, exactly 4, exactly 5. I stop at 5 because that's how many girls I have total. On the other hand, if I had more girls, we'd have to keep going. Understanding that, it helps us solve a lot of problems. So we could go through things and say, all right, say, example, at least, say, 3 girls. If I have at least 3 girls, that's just equal to exactly 3 or exactly 4 or exactly 5. If I find those 3 values and simply add them up, it would satisfy the at least 3 girls. And so exactly 3 girls would be of the 5 girls choose 3, and then from the guys choose 7, or from the 5 girls choose 4, and then from the 11 guys choose 6, or from the 5 girls choose 5, and then from the 11 choose 5 equals, and you would need to finish that. Put that in factorial notation, and you could still figure out what this number is. But it's just a straightforward application of it. On the other hand, it would probably be easier if I said things like at least one girl. I could do exactly 1, exactly 2, exactly 3, exactly 4, exactly 5. I don't want to. This would be the same thing as all minus no girls. Well, what's all? That is 16 choose 10 minus what's no girls? Well, 11 choose 10. And so right there, obviously you still have to finish this in finish using factorial notation. So it still needs to be done at home, but this is the setup for it, where all minus girls tells you that what's left over is teams that have at least one girl. This also gets us to, if we would look at this particular problem, especially here on the 5 choose 5, it gets us to a nice little definition. Definition. 0 factorial is simply 1. Okay, one of the questions is, say, why? Well, what if I had a problem that said, what is 5 choose 5? Which is going to be 5 factorial divided by 5 factorial, 0 factorial. Well, what I know is that 5 choose 5, which is you have 5 kids, you need to choose 5 to go out and play. You just simply, there's only one way to do that, right? It must be 1. And there's only one way to send 5 players from 5. It just is simply everyone goes, right? That's it. Everyone is going to go on this particular problem, so I know it's 1. So now I have 5 factorial divided by 5 factorial, z fact must be 1, because I know that just happens. Well, the 5 factorials cancel, so that tells me that 1 over 0 factorial equals 1. The only way for this to happen is that 0 factorial is simply 1. And what's the idea behind it? The idea behind it is, when I say choose, what does it mean? Like 0 factorial would be like choose no one, if we would do it that way, or arrange no one. If we take the idea of the choice function, which is assign people, 5 choose 5 would tell you, hey, all 5 play, and that leaves you nobody on the bench. And how many arrangements of the bench do you have? 1, right? Nobody's arranged. It's the same thing as saying everybody go to the bench, and which is 5 choose 0 going out to the court. So both of those approaches of choosing no one or choosing everybody has one way of arrangement. It's just simply, selecting all or selecting none. 0 factorial represents that, and there's always one way to do this.